All right. I would like to welcome the next speaker, Nunes from Red Hat, talking about the Vulkan renderer for Weston. Welcome.
Hello. Hello. Hi, everyone. So I'm Erico. I work for Red Hat. I want to talk about something I worked on in the past few months, which is a Vulkan render for Weston. So I guess many people here may already be familiar, but first of all, what exactly is Weston? So Weston is a Wayland compositor. In fact, it's the first Wayland compositor that still exists inside the Wayland namespace. So it's something that kind of was born together with Wayland. And well, the compositor is the application that runs in your system that takes the contents of all of your application windows, which are your Wayland clients, and put it all together into this image that is the thing that finally goes to your screen, or that finally goes to your desktop that you can get on the screen, or perhaps remotely, or in some other way. But the compositor is the application that takes all of the contents of your windows and put it all together. So how exactly does it do that? So not only for Weston, but it's also the case for most of the other compositors as of today. If you want to do this process, this composition process using your GPU, it's most likely use OpenGL, and the compositor is going to have some kind of OpenGL render component. In Weston, it's called the GL render. And it's going to use your OpenGL driver. It's going to basically use all the contents of your windows as a texture, and it's going to render a rectangle with your texture. And putting all those rectangles together, that's basically the result that the compositor puts on the screen. So this is actually pretty good. Most platforms that exist today have OpenGL drivers. Mesa has OpenGL drivers for pretty much every GPU that you can think of, and both the GeoRender and the OpenGL drivers have been optimized for 10 years or more. So this actually works pretty well. Now, some more modern platforms are starting to actually not have an OpenGL driver. So basically, OpenGL is already kind of a dating API. There are more modern APIs coming on, for example, like Vulkan, like in the title of the talk. So as a thought exercise, if you didn't have an OpenGL driver, how could you run a compositor today? And one of the ways in which you could do this is to use some kind of a translation layer. Thankfully, in Mesa, we also have this awesome project called Zink. It's an OpenGL implementation on top of your Vulkan driver. So basically, even if you only had a Vulkan driver, using this sort of architecture would still solve the problem, and you'll still be able to use all of your compositors that have OpenGL renders, as well as all of your applications clients as well. And there's also nothing wrong with doing this. Zink is pretty awesome, and nowadays we are having more and more Vulkan drivers for the platforms. I just wanted to clarify here. So when I'm talking about a Vulkan render for Weston, is of course to have the capability of Weston directly using Vulkan API directly, which is on top of your Vulkan driver. And just looking at this difference, there's maybe already some things you could point out. For example, maybe there's advantages of doing this because it's like less components in the stack. Vulkan is a more modern API. Perhaps you could have less latency, less overhead. Vulkan is more explicit. Perhaps you could have more control, more performance, or something like that. But there's a bit more to that. And in fact, believe it or not, nobody has worked on a Vulkan render for the entire existence, at least for Weston, for the entire existence of Weston. And there are not so many Vulkan renders available for most major compositors today, with a few exceptions. So how come that nobody has decided to work in this? So my thought is that because basically the first two architectures basically solve the problem for pretty much every use case that you can think of, so nobody had to do this. So why did I do this? Why would anybody do this? And I wanted to bring the use case a little bit because it's very important for some of the decisions that I made while working in this implementation. So when I'm talking about all this stuff, normally I'm thinking about this type of boards. I might be a little biased because of this, and you might have like a different image in mind, but then I'm thinking about the Vulkan implementations, Vulkan drivers, whatever. Usually I'm thinking about some kind of an embedded system like this, which is what I've been working mostly in lately. And the backstory of this is some years ago, for various reasons, I wanted to contribute to the PowerVR driver, which you might have seen is from Imagination Technologies. A couple of years ago, they released open source drivers in both the kernel and in Mesa, which are upstream now. And my goal was to help the driver progress and evolve a little bit faster so that it becomes usable. And after talking with the people from Imagination, well, they already had a bunch of development going on in their own branch, so I didn't want to do anything conflicting with what they're doing. Just the Wayland WSI part is something that was basically unclaimed. Nobody was working on that, so it's something that I could pick up. It's hardware independent, so I could do some work, enable the Wayland WSI. Perhaps for the first time, we could run some Wayland application. Instead of running only, for example, the CTI test to get the Vulkan on zero compliance, which are not very exciting, you could finally run some Wayland applications. You can run like first Wayland triangle or something like that. And yeah, maybe doesn't sound too hard, right? How could you do that? Step one, add Wayland WSI to your driver. That's actually easier than it sounds. There are many other driver examples you can copy off. And there are many other references on how to do this. Actually only requires a few extensions and a few Vulkan callbacks to be implemented, and your driver now supports Wayland. Step two, which compositor are you going to use to test your Wayland application on? Can you just pick any compositor? We don't have an OpenGL driver. PowerVR implements only the Vulkan driver, and it relies on the Zink implementation, which is still perhaps not there. So you cannot just pick any random compositor and start and use that to test your Wayland WSI implementation. Can you use Zink? Well, the support is still in progress. In fact, now it's been a couple of years, and we are finally getting there, but there's still driver enable that needs to be done. So Zink is not exactly something you get for free when you have a Vulkan 1.0, for example, implementation. So that's not a trivial option as well at this stage of development, I would say. I know, I have another idea. WL Roots actually has a Vulkan implementation, so maybe we can just run that, and then I can finally render my Wayland triangle. Well, we are still trying to achieve Vulkan 1.0 compliance, and just the first thing it will require is Vulkan 1.1, plus a few extensions. Perhaps I could hack around that, delete some extensions, lie that I have some extensions or something, and then I can finally have a compositor running. But that's not really what I want to do. It doesn't scale very well. Like, other people will not be able to do this. My final idea, perhaps I don't care if the compositor is slow or not. Maybe I can run the compositor with software rendering, and as long as my driver can render with the Wayland WSI and send it to the compositor, I don't care if the compositor is slow. So maybe I can just use this for a while until the other things are ready, so I can test that I can finally render a Vulkan Wayland application with my driver. Oh no, that will not work either. We don't get exposed the Linux DMA buff, so you cannot run actually a Vulkan client if you're using the software render compositor. So it would be really nice, if Weston actually had a Vulkan render, which was simple, which didn't require a lot of extensions. Weston actually has a bunch of other debug features that you can use. You can do things like off-screen and some other nice like debugging feedback or something like that. So how hard could that be? I heard this many times during the conference. How hard could it be? Well, after 3 months or something, 3-4 months, I accidentally became a Weston contributor. I did the implementation of the Vulkan render, and this is more or less the situation where it is right now. And the first one is something that I actually wanted to bring for discussion here, as I'll show later on. The design is entirely based on a Vulkan 1.0 implementation base with a bunch of extensions. And as much as completely possible, every extension that can be used is optional. The thing is that a lot of the extensions are only required if you're using a particular workflow. For example, a lot of the extensions related to DRM are only relevant if you're actually using the DRM backend. So if you're using something like the headless backend or the pipewire backend or something, you don't actually need those. So requiring those as a mandatory thing in the beginning actually limits you from being able to launch it, for example. And I didn't want that to happen. So I know this can also be a little bit controversial. There's basically a bit of a push for Vulkan applications to switch to the more modern models. Basically, when you go like to Vulkan 1.3 or something, Vulkan has changed a lot over time, and a lot of these Vulkan 1.0 workflows are not really recommended anymore, at least for applications. So someone might disagree with this, but coming from the background that I came with the new Vulkan driver, that's a strong decision that has been into this implementation. Yeah, it's already merged basically for Weston 15, which is still unreleased. When it is, you can basically pass --Vulkan equals render, render equals Vulkan, and you will get exactly the same thing as before, except it's gonna be using Vulkan. Some additional things that went with it, the Weston CI test. So Weston has some pretty cool CI that runs a bunch of Wayland tests at every merge request. And from even the initial implementation, I already added support for all those tests to run with the Vulkan render. So it's CI from the day one, basically. So that was pretty cool. And new demos, yeah, so that Weston ships a few demos like the spinning triangles or something. I also have new versions which use Vulkan instead, so you can use that as like a first test. If you're sick of running VK-Cube, you can run some like Weston Simple Vulkan, which is exactly that one. And something that I kind of skipped, but Weston supports various backends. I guess the one that most people would be more interested in is the DRM backend, which would be actually to render to your screen. But there are a lot of others. For example, there's Wayland and X11 that you could run like a nested compositor. If I have time, I'll show some demo. And headless backend is actually super important. It runs all the tests in CI, and it can be, for example, the first thing that you can launch just to initialize the device and being able to run some first clients just to see that it actually boots and starts running. And the VNC and RDP and Pipewire are, you can use it like kind of as a remote desktop thing. I've been using the VNC backend actually quite a lot, because even if your driver cannot yet work very well with DRM, it's a very good option. It's very similar to the headless backend, except that it will stream the contents of the screen to over VNC, and it has basically no requirements on implementation with DRM. So you can see the result even in a remote system, and it's actually going to be using Vulkan. So that's actually a great way to test the driver for the first time, that it's able to interact with the Wayland compositor and render everything with the GPU, with Vulkan, and actually see the result in real time. And finally, all the other features that you expect from Weston, like you can use multiple outputs. Yes, you can actually mix and match. There's like a new feature in Weston. You can use at the same time, you can do like a DRM backend and like a Wayland backend, or you can do VNC and RDP at the same time, and if you drag the window from one to the other, it shows in the other one. It's really cool. And, well, X-Wayland as well, and everything else you would expect. Now, I do still think that it's probably, if the GL render is working for you for the application, or if perhaps if it's already using Zink or something, there's really no reason to change that. So in my opinion, there is actually a fairly limited number of use cases to actually use this at this moment. And I would love to hear more if somebody has some more opinions. But basically, these platforms which only have Vulkan drivers would be one of the major use cases for this. Development and testing of the compositor, perhaps the driver integration with the compositor is something that there has been a little bit of a gap, in my opinion, and this project can now be used to increase the testing and coverage for that part of the driver. So that's something where I think it will be particularly useful. CI for Vulkan drivers. So, for example, if you're going to enable in Mesa CI, for example, for the Power VR driver, which is only Vulkan, perhaps this would be a way to enable WSI tests at first before having to wait for the entire Zink enablement. Then there's a lot of embedded use cases where perhaps you would be interested in something like lower latency or whatever Vulkan optimizations that there might exist. Maybe in that case, let's say even if you have an OpenGL driver, but your entire application stack is already Vulkan, and then you can also use now the Vulkan for the compositor. So that means you don't even have to ship the OpenGL driver anymore. Maybe it could be like a smaller system or something like that. So there's this option now. And maybe somebody is interested in just using Vulkan because it's Vulkan and because it's newer or something. That's also an option now. So this is the last thing I have. I do have still some challenges left. The buffer allocation still uses GBM, which at least if you're using Mesa drivers in these embedded platforms, it goes to a Gallium driver, which basically means it goes to your OpenGL driver. But if you don't have one, then that means you cannot use it. So if you try to use the DRM backend by Weston by default, it will go to GBM. So that's kind of still a blocker, basically, because if you don't really have an OpenGL driver, it didn't really solve the problem, right? You can still use this, for example, with the VNC backend to test that the driver integration with Wayland is working, but it's still a little bit blocked on actually being able to run it with the DRM backend. And then finally, the DRM backend by itself is certainly the most challenging part of the project. And I've already rewritten it like 3 times, and we're still fixing a little bit of the corner cases that happens with drivers that we didn't test before. Mostly things related like to modifiers, for example, or like negotiating with modifiers can be used for the DRM main frame buffer. Then something I would really like to hear feedback from people. Can be positive or negative, I don't care. I just want to hear some sort of feedback on this. But like I mentioned, there is a lot of push from not basically using this Vulkan 1.0 style of development anymore. But at least for the moment, I'm quite convinced that Weston is a good place for this to exist, because in my opinion, somewhere there needs to exist some sort of Vulkan 1.0 style type of applications that you can run when you have a driver which is still being brought up. If every application would start requiring Vulkan 1.3, 1.4, then if you start a new driver, then basically you cannot test anything until the driver is ready, but it will never be ready because you cannot test it. So there's this kind of a gap, and I feel like Weston as kind of a development embedded-ish type of project, as opposed to, for example, the more or desktop-oriented projects, is a good place for this to exist. Yeah, and if you have some more use cases, I'm happy to hear that. this is a kind of a to-do list of features which are still not there, and I plan to work on those next, perhaps in no particular order. I'm a big fan of the debug binding, so that maybe that's the easiest thing which will come first. And now I'll try to show you a less than 1 minute demo. So I don't know if you can see that. I'm typing here Weston dash render equals Vulkan. What did I type? Okay, there you go. So as you can see, it's exactly the same thing as before. I think the most interesting thing here is that you can see the driver, the Weston loaded the Vulkan render, which is like this object, and this is the entire list of extensions which are actually checked, which are actually all true for my laptop at least. And yeah, that's it. Any questions?
All right, thanks a lot. So we are at time, right before the lunch break. Yeah, I think if you have any questions, maybe you can just assemble here right after the talk, so we don't take the time away from other people getting lunch. Yeah, thanks a lot.